Okay. So in general term, what is defined scale? In general term, what is defined scale? Have you seen the term scale on your drawing sheet? Yes or no?
Sir.
Yes. Where you have seen? At the bottom, you will be having the scale. What you are writing in that scales? Why? What you are writing and why you are writing? Yeah. Any EI student?
Sir, is it new chapter?
Yeah. No. Sheet number 4.
Sir,
Conic
we have
sections.
triple E also, sir.
What? Once again, repeat.
Triple E also, sir.
Yeah, triple E, same thing. It is syllabus is same for triple E and EIE. All is the same. Yeah.
Okay, sir.
You
Thank you.
on this sheet you have scales written on your drawing sheet. Scales has been written. Scale. What is the term you write to fill in the scale?
1:1.
1:1.
1:1. So in max term, what is meant by 1:1? In the max term, what is meant by 1:1? It is called as numbers, decimals, ratios. What is called?
Ratio.
Ratio. So what is meant by ratio? Ratio has a numerator and
Denominator.
denominator. So here what they tell in the scale is numerator is 1 and denominator is 1. So numerator is 1, denominator is 1. So why we are considering the numerator and denominator? That's the main question. Why we need to consider the numerator and denominator question. Suppose there is a new building or a house that you want to draw it on a drawing sheet. Is it possible to draw a building or house on the drawing sheet? Yes or no? Because your drawing sheet is very small. On the drawing sheet, is it possible to draw a building or the outline of your house? Possible? Yes or no?
No.
No, not possible, because your drawing sheet is small and your building is very large, because the building is around example 10 meters or suppose 150 yards. Generally we takes the measurement in yards, feet or inches of anything. Okay, so it is not possible to draw when you are, it is not possible when you are taking exact dimension. suppose it is Suppose it is 150 feet. Example, 150 feet is the distance or 160 yards is the distance. That 160 yards you want to represent on drawing sheet is not possible when you are taking exact dimension. Exact 160 you want to take, you want to keep the drawing sheets n number of 100 of drawing sheets in a single row, then you can able to draw. But but if you want to draw, we have to reduce the scale, reduce the size. Example, in your school days you have seen the world map. So if you see the world map, this is your world map given on your drawing map. So what they do is, here can you see this one? This is the scale. They mention the scale. They mention scale such a way that 1 mm, 1 mm represented on the world map equal to 10,000 kilometers. Suppose this 1 mm, this 1 mm I am drawn, this 1 mm equal to 10,000 kilometers. So that is the reduction, or that is the scaling they have made. So it means that numerator is scale they have reduced, so it is less than 1. So it is numerator will be less and denominator will be more. Okay, so it has been reduced to scale. Similarly, if I want to draw a world map, I have to use the scales concept to reduce the dimension, and I'm drawing. If I draw the 1 mm on the world map, it represents 10,000 kilometers. 1 mm, that's the representation of scale here. This is the one they mentioned. Okay, and if you want to draw very small objects such as any gates in a watch, if you see any mechanical watch, there's a small gear like structure here. This gear like structure will have the teeth, gear teeth. These gear teeth are very small, such as 0.2 mm, 0.1 mm, very small. If you want to draw the 0.2 mm, 0.1 mm, it will just like a point on your drawing sheet. So what we do is, we will enlarge. The numerator will be more and denominator will be less. We'll enlarge, we'll make the twice the dimension, thrice the dimension, then we can draw. Scales is nothing but we are either reducing the size of an object whenever the object is larger than our drawing sheet. Whenever the object is larger than our drawing sheet, we'll reduce the size of the object. Whenever the size is very smaller than the drawing sheet, then if we are unable to draw, then we will enlarge the size and we'll write. So in your previous sheets 1 to 3, we take the exact dimension. We have doesn't reduce the dimension, we haven't increased the dimension, we took the same dimension. That's the reason we are writing scale 1:1. Numerator is 1, denominator is 1. Whatever the assumption we are drawing on the drawing sheet length is same, and whatever the actual length, actual dimension and drawing dimension on the drawing sheet both are same, then we have to write 1:1. If we are reducing, if we are reducing this reducing, then denominator will be higher value. If I am enlarging, the numerator will be more. Okay, so this is a basic concept of the scale. So whatever maybe the whether the object is higher than your higher dimension than your drawing sheet or lower, very lower dimension than your drawing sheet, you are able to draw by using the scales concept. So that's the reason every drawing sheet will have the scales, because the other person should understand whether you have reduced the scale or exact dimension you have used. That other person need to know. That's the reason we will be, every drawing sheet will have the scales. Okay, yeah. So this is the same introduction whatever I explained. What are the objects we see in our day-to-day life has different sizes. All the objects are not in same size or same shapes. All the different objects, different sizes. So when we are representing any object on the drawing sheet, either we have to reduce the size of the object or enlarge the size of object, or else exact size. Either we are reducing the size or enlarging the size or exact size we have to use. It has to be represented in the standard units. Suppose I'm so 1 kilometer, so I'm taking the standard unit as meter. So meter, I'm taking the standard unit as meter. That meter only I have to convert in terms of meters only. That meters I cannot convert into feet. That meter I cannot convert into inches, because meter is different. Meter is a metric unit and feet and inches are the British units. So imperial units we call it as. So that's the reason we don't compare. We have to take the standard unit. If I'm taking meters, meters can be converted into centimeters. That you have to take. Okay, meters, if you are converting meters into feet, that will be, you have to use another formula. Okay, can anyone tell me 1 meter equal to how many centimeter? Can anyone tell me 1 meter equal to how many mm? How much mm? It is 1 meter equal to how many mm?
1000.
1000. Is it correct? 1 meter equal to 1000 mm. So 1 mm equal to 1 centimeter equal to how many mm?
10.
10 mm.
10 mm.
10
So yeah, so whenever you are converting, you have to take the standard units, either metric units. These are things you have to learn. I will show you few of the things how to convert. Okay, and one more thing. Suppose you take gram. Example, one of the unit to measure the weight is gram. So what is higher than the gram? Anyone know? Kilogram. So 1 gram higher than gram is kilogram. Then 1 kg 1 kg equal to how many grams?
1000.
1 kg equal to 1000. Okay, 1 kg equal to 1000 grams. So kg full form is kilo. Kg full form is kilo. So kilo is nothing but 1000. We take kilo as 1000. Similarly, 1 second, there is a 1 second example. Second is the unit of time. So 1 second I have taken. So this 1 second, what is the lesser than 1 second? Anyone know what is less than
Milliseconds.
millisecond? Okay, so millisecond. So 1 second equal to how many milliseconds? Anyone know?
100.
1
60.
1 second
100.
equal to how many milliseconds is 100 milliseconds. 100 milliseconds. So milli is nothing but 100 or 1000. Check 1 second. So milli. So suppose if I measure anything in meters, 1 meters equal to millimeter. I have asked 1 meter equal to how many millimeters. I have asked. Milli is nothing but 10 to power of 3, 10 to the power of minus 3, 1 by 1000. If I take 1 by 1000, then it is milli. I call 1 meter. I have to convert into millimeter. Milli is nothing but 10 to the power of minus 3. So like that, you have few abbreviations such as 10 to the power of 1, 10 to the power of 2, 10 to the power of 3 is the highest value. Similarly, 10 to the power of minus 1, 10 to the power of minus 2, 10 to the power of minus 3 is the lesser value. So I'll show you the table so that you can all the standard units are represented as. If you see, this is my standard 0 1. If I want to make 10 to the power of 1, it is called as deca. So similarly, if you want to consider as 10 years, we call decade. Decade is nothing but 10 to the power of 1. So for 1 year, I'm multiplying it to 10, then it will become a decade. Similarly, if I want to find out 10 square, 10 to the power of 2, it is called as hecto. We call it as hecto. Similarly, 10 to the power of 3, we call it as kilo. Similarly, if I want to make 10 to the power of minus 1, it is deci. Similarly, 10 to the power of minus 2 is centi. 10 to the power of minus 3 is milli. It is represented by tenth, 1 by 10th, 1 by 100th, 1 by 1000. So if you take it in terms of decimal, 10 to the power of 0 is 1, 10 to the power of 1 is 10, 10 to the power of 10 square is 100, 10 cube is 1000. This 1000 directly we called as, instead of saying every time 1000, we call it as kilo. Instead of saying every time 100, we call it as hecto. Instead of saying every time 10, we call it as deca. Similarly, whenever we want to represent 1 by 10th or 10 to the power of minus 1, yeah, everyone mute yourself. I don't want any disturbance. Any doubts? I will ask you any doubts. At that time, you can unmute. So similarly, anytime, similarly, if I want to make 1 by 10th, then it is called as deca. 0.1 is deca, and 0.01 is centi, 0.001 is milli, is nothing but 1 by 1000. 1 by 1000. Suppose meter is the standard distance we take. So this is called decameter, hectometer, kilometer, decimeter, centimeter, millimeter. Suppose here we take it as gram. Decagram, hectogram, kilogram, decigram, centigram, milligram. Suppose we take the standard unit as second. Decasecond, hectosecond, kilosecond, decisecond, centisecond, millisecond. We call in these terms. Okay, and everything has a shortcut symbols. So kilo should be represented as by the letter K. Hecto should be represented by the letter H. Deca should be represented by letter DA. Deci, because DD are common, so deci will be represented as the letter D. Centi is represented with the letter C. All these are small letters. Don't consider this as capital letters. It is a small letters. Milli we consider as M. So suppose if I take standard unit as meter, this will become a dm, decimeter. So if I write anywhere dm, it is called decimeter. Anywhere if I write cm, small letter cm, it is called centimeter. Wherever I write small letter mm, it is called as millimeter. Similarly, wherever I write DAM, small, all small letters, DAM if I write, it is called decameter. Wherever small, if I write HM, H small letter, M small letter, it is called hecto. Wherever I write KM, it is nothing but kilometer. Okay, so these are the standard things you have to understand before starting the scales. Okay, any doubts you can unmute and you can ask, because I'm changing the slide. Any doubts you can unmute and you can ask, or else type in the chat. I hope no doubts. Okay, so I'm going to the next slide. Yeah, so metric units, there are two types of units. One is metric units and imperial units. Metric units, few of the countries will use metric units, few of the countries will use imperial units. So I gave the relationship. What is the relationship between meters, decimeter, centimeter, millimeter, and what is the relationship between meter, decameter, hectometer, kilometers in terms of millimeters? Suppose I'm taking millimeters as the standard one. Suppose I'm taking millimeter as standard one, then centimeter will become as 10 into 1, 10 mm, and 1 mm equal to 10 square. 1 mm equal, 1 decimeter equal to 10 square mm, and 1 decimeter equal to 10 centimeters. Similarly, for meters, 1 meter equal to 10 to the power of 3 mm, and 1 meter equal to 10 square centimeter. 1 meter equal to 10 dm. Dm is nothing but decimeters. Every time you have to write in small letters, not in capital letters. Okay. Next, decameter. 1 decameter equal to 10 to the power of 4 mm, 10 to the power of 3 centimeters, 10 to the power of 2 dm, and 10 meters. 1 hectometer equal to 10 to the power of 5 mm, 10 to the power of 4 cm, 10 to 10 cube dm, 10 square m, and 10 dam, decameters. 1 kilometer equal to 10 to the power of 6 mm, 10 to the power of 5 centimeters, 10 to the power of 4 dm, 10 to the power of 3 m, 10 square dam, and 10 hm. So these are the things you have to understand before starting the problem. In the problem, they say that represent 10 kilometers and hectometers. So you have to know 1 kilometer equal to how many mm. 1 kilometer equal to 10 to the power of 6 mm, and 1 hectometer equal to 10 to the power of 5 mm. These are the values you have to know before starting the problem. If you don't understand this, you don't understand the problem. Okay. Any doubts, you can unmute and you can ask. Any doubts, you can unmute and you can ask. Okay. So I hope no doubts. I hope no doubts. So I'm going to next. So apart from metric units, in the metric units, generally Americans use metric units and Indians follow Americans. So in India also we use metric units, but there are few European countries which doesn't follow metric units. They follow their own units such as inches, foot, yard, chain, furlong, mile. Okay. So example, inches. If it is very small, they don't consider as mm. In the European countries, they consider as inches. Suppose if you want to measure the height, you generally you don't tell your height in terms of centimeters or millimeters. Generally, you tell your height in terms of feet and inches. Suppose 5 feet 9 inches, 6 feet 2 inches. You tell the height in terms of foot, in terms of imperial units. Similarly, if you want to measure the distance of a cricket pitch, it will measure in terms of yards. Wherever you want to keep the distance of the cricket pitch between the two wickets on the both the ends, it will measure in terms of yards only, not in terms of centimeters or millimeters, because cricket was invented by the British. In the European countries, they follow only imperial units. They doesn't follow metric units. So if you want to uh, explain your drawings to the other European countries, you have to follow imperial units. You have to use inches, foot, yard, chain, furlong, mile. So there is a relationship, 1 inch. Generally, if you want to represent the units of the inch, I write IN in small letters, or else 2 hyphens I can write in inch. If I want to represent foot, FT I can write, or 1 hyphen I can keep. And 1 foot equal to 12 inches. So if I want to measure 1 foot, 1 foot equal to 12 inches. So you can't say that I am 5 feet and 12 inches. You can't say. You directly say that 6 feet in height. You can't say that 4 feet 12 inches. You will say that 5 feet, because 1 foot equal to 12 inches. Similarly, it is important. I'm going slow because it will be asked in the exam. They'll give the 1 yard equal to how many foot? 1 yard equal to 3 foot. Like that, you have to know 1 yard equal to 36 inches. Next, they'll ask the chain. Any problem they can ask in the exam. Okay. Next, chain. 1 chain equal to 22 yards. 1 furlong equal to 220 yards. 660 feet. You can because the calculators are allowed in your exam, so that you can calculate on your own. No need of by having this one. Just know that 1 meter equal to 10 10 to 1 kilometer equal to 10 to power of 6 mm, and all these things you have to know. These you can calculate if you know the what is the relationship between millimeter, centimeter, centimeter, decimeter, decimeter, meter, meter and decameter, decameter and hectometer, hectometer and kilometer. If you know the relationship, then you can calculate. Calcis are allowed. In the calcis you can calculate. Okay, 1 foot equal to 12 inches, 1 yard equal to 3 feet, 1 chain equal to 22 yards. Like this you have to calculate. So generally the problems don't go beyond the yards. So till yards you have to remember. Minimum you have to remember till yards. Okay. So one person asks, what is FT or hyphen? So generally what we do is, whenever we are measuring the units, I can write 3 and this one. It means that it is 3 feet. It means that it is 3 feet. Whenever I write 3 feet and 7 inches, then whenever I want to represent 3 feet 7 inches, I'll write this 3 feet and 7 inches. So this is the symbols we follow for the, yeah, this is the symbols we follow for the writing represent the value. Suppose it is how we write 3 centimeters and 7 mm. Similarly, instead of writing the letters, they don't use letters, they use these symbols. So I'm writing it as suppose 5 feet and 9 inches. So you have to represent like this. This value represent 5 feet and 9 inches. Okay, instead of writing centimeters mm, they don't use the letters. Instead of letters they use symbols, 5 feet and 9 inches. Okay, so either you can write FT for representing feet, or else you can use this symbol, so that anything is correct. Or is nothing but either you can use this symbol or this letters or this symbol, anything you can use. Okay, and metric units, these are the metric units and these are the imperial units. In all the European countries they'll use only imperial units, they don't use metric units. Okay, all the countries related to America, they will use metric units. Okay, and there's one more conversion. There's a conversion of imperial units to metric units and metric units to imperial units. Okay, and if I want to convert 1 inch into centimeters, 1 inch equal to 2.54 centimeters. If you in few of the scales also this is mentioned. Okay, 1 inch equal to 2.54 centimeters. So similarly, if you want to calculate foot, 2.54 into 12, if you make, you will get 1 foot. What is the value you will get? If you want to
So
measure
1 feet, 1 feet equal to how many inches, sir?
1 foot equal to 12 inches. Feet is a multiple. If you is more than one, then you call feet. If it is only single one, we call it as foot. Okay, 1 foot equal to 12 inches. If I want to convert foot, so 1 foot equal to 12 inches. So 12 into 2.54. If I make, I'll get this value. So you can use a calci and you can calculate. If you forget anything, you can use a calci and you can make 1 yard. 1 yard equal to 3 feet. So 3 into 30.48. If I make, then I'll get 91.444 centimeters. Or in terms of meters, if I want to convert 1 yard into meters, it is 0.914 meters. And 1 mile. So generally in the European countries, they doesn't consider kilometers as the distance. They say that it is 10 miles, 12 miles. They call it as in terms of miles. And in the European countries, they doesn't take weight in terms of kgs. They take in terms of pounds. So similarly, there will be some conversion. So similarly, mile, 1 mile equal to 1609.344 meters. So this meters, because 1 mile equal to 760 yards. So you have to multiply 760 into 0.914, then you will get this value. In terms of kilometers, if you take in our India, if it is 1.609344 kilometers, then they in the European countries they call it as 1 mile. They measure the distance in terms of miles, 10 miles, 2 miles, 2.5 miles. They measure in the terms of miles. So you need to know the conversion. In the exam, they can ask either imperial units or metric units. If they ask in imperial units, because in India we use metric units, so you have to convert that imperial unit into metric units. Okay. Yeah. Next, same thing, reverse, metric units into imperial units. So 1 mm equal to 0.03937 inches, and 1 centimeter equal to 0.3937 inches. 1 meter equal to same thing, whatever mentioned, same thing. 1 kilometer equal to 0.62137 miles. So in the European countries, if you see that it is 1 mile, Then in Indian terms, it is 0. This is a value. If you 1 kilometers, this is the miles, in terms of miles you are making. Any doubts, you can unmute and you can ask. You can take this screenshot so that it will be helpful for you. Okay. When I'm solving the problem, that I will solve. At the time, I don't explain what is the conversion. You have to make the conversion. You have to understand all these tables. Okay. I'm going to next slide. So next slide will be, so now you have seen that standard length. Length is a one-dimensional element. Length is a one-dimensional element. What is a two-dimensional element? Can anyone know what is meant by two-dimensional element? Anyone? What is
Area.
area? So if I take area, it will become length and width. It will become area. So if I want to calculate area, can anyone tell me what is the area of a square?
Side square.
S square. So suppose this is the my L distance. This is my same distance. If I'm taking L, then L into L, area will be L square. Okay. Suppose this is a rectangle, L into W. So what will be the area of rectangle? Anyone? What is the area of rectangle?
LW.
LB. We call it as length
Into
into breadth. So here, if it is a square, it will become L square. If it is this area, if it is a rectangle, it will become L into length into width or breadth. It will become. What is the third dimensional? 3D. 1D is the length, 2D is area. What is the 3D?
volume.
Volume. So in the volume, what happens is we have length and width. For this length and width, we are giving thickness. We are giving thickness at certain distance. We are giving the thickness. Okay. So this will be your length. This is your width, L, W, and H. This is your L. This is your W, and this is whatever may be the this distance. This distance we call it as H. L, W, H. So if I want to calculate the volume, what I do is, if it is a square, if it is a square cube, if I want to calculate the volume of a cube, it is S cube. S cube. If it is any other dimension, then length into width into height, then I'll get the area, then I'll get the volume. For the length, directly I'll measure the L. For the area, I'll measure length into width. For any volume, length into width into height. If I make, then I'll get the area. So similarly, the same concepts, what are the concept you learned in metric units and imperial units, this same concept will be applying for the areas and the volumes that you will be seeing in the next slide. So if you see the standard area, if you want to measure any of your house, you measure as it is in a square kilometers or hectare. You call, if you have any paddy fields or any field, they'll measure in terms of hectares. 1 hectare equal to 10,000 square meters. So you have to know. So here what happens is, I'll explain. Suppose you already know that 1 centimeter equal to 10 mm. You already know that 1 centimeter equal 10 mm. So here what happens is, this side is 1 centimeter, this side is 1 centimeter. So this is 1 centimeter and this 1 centimeter. So what happens is, so 1 centimeter into 1 centimeter. So we called as 1 square centimeters, 1 cm square we called, because we have multiplied 1 centimeter into 1 centimeter, 1 into 1, it will be 1, and cm into cm, it will become cm square. And here also we multiply 10 mm. Already we know that 1 centimeter equal 10 mm. 10 mm into 10 mm. 10 into 10, it will become as 100. And mm into
Excuse me,
mm.
sir.
Yeah.
Excuse me.
Yeah.
Who is roll number 258 and 1029? Just mute yourself.
Sir, you can mute yourself. Sir, in the
Actually,
options, you are
I
logging
signed
from
in from
mobile.
two devices.
Okay.
So
Okay, I
that's
will
why
make you as co-host so that another device also will make co-host. You can click on mute. Yeah. So whenever you want to convert 1 centimeter into mm, we know that 1 centimeter equal to 10 mm. But for the area, what we do is 1 centimeter into 1 centimeter. So 1 into 1, 1 centimeter into centimeter. It will become centimeter square. Similarly, if I want to, this is the 1 centimeter equal 10 mm. 10 mm into 10 mm. 10 into 10, 100. Mm into mm, mm square. So like this, you have to calculate. 1 square centimeter equal to 100 square millimeters. Similarly, 1 square meter equal to 1000 into 1000. It may 1 meter equal to 100 centimeters. So 100 into 100, 10,000 square centimeters. Like this, you have to calculate. Okay. Similarly, for foot, 1 square foot equal to 12 into 12, because we know that 1 foot equal to 12 inches. 1 square foot equal to 12 into 12. It is 144 square inches. We know that 1 yard equal to 3 feet. One 1 yard equal to 9 square feet. 1 square yard equal to 9 square feet. So like this, you have to calculate. So it is easy. You can calculate because calcs are allowed in your exam. If any problem asked on the areas, you can calculate on your own, because in the problem they can ask on the length, on the area, on the volume. Okay. Same concept is kept for the volume also. Yeah. Whatever I'm 108 8 roll number from EIE. So it is a little bit practice once, it will be easy. And whatever I'm explaining, it is not guaranteed that everything will be asked in the exam. Few topics will be asked, few topics you have to understand on your own. Okay. Similarly, for the volume, 1 cubic centimeter, because we know that 1 cm equal to 10 mm. So 1 cube cm cube equal to 10 cube. 10 cube is nothing but 1000. So it will be 1000 mm square. This whatever I'm saying today in this till now, it is a basic common things wherever you observe. If you want to buy any area land, if you want to buy any land, they measure in terms of square foot. They say that 130 square foot, 230 square foot, or they measure in terms of yards, or they measure in terms of hectares. If you want to buy any fields, agriculture lands, they'll measure in terms of hectares. So these are common things we will be using in day-to-day life. If you are very familiar to buying and selling the lands and other things, it will be equal. And you already know 1 mm equal to centimeters. After centimeters, what are the things are there you have to learn. Okay. So you know already millimeter above centimeter. After centimeter it comes decimeter. After decimeter it comes meters. After meters it comes decameter. After decameter it comes hectometer. After hectometer it comes kilometers. So like this, you have to remember these things. These things are compulsory. You have to remember what are the different stages of converting millimeter into kilometer. These things compulsory you have to know. These things either you by heart or learn, understand anything. This thing compulsory you have to learn. How the millimeters, what are the steps to become from millimeter to kilometer. Okay. Yeah. So these are the topics, few topics. How to measure the length to 1-dimensional, 2-dimensional, and 3-dimensional. Okay. So I'll start the scales topic. Actual scales topics start from now. Okay. So already I told that scale is 1:1. You write 1:1. So this 1:1 is the what are the drawing you are drawing on the drawing sheet by actual dimension. Suppose your building is um, 10 meters. Example, your building is 10 meters, and you are drawing. Then you are reducing the size to suppose 10. So what will happen is you are reducing the size and your actual size. Actual size is 10 meters, and you are reducing the size. So based on that numerator and denominator by scale ratio, you will be making it. So whenever you are drawing exact size, full size scale, it is 1:1. Numerator is x, denominator is y. Numerator equal to denominator, full size scale. Reducing scale, denominator is greater than, y is greater than x. That is reducing scale. Okay. And whenever enlarging scale, whenever we are making the object more, we are giving double dimension, triple dimension, numerator will be more compared to the denominator. Numerator will be more compared to the denominator. Okay. These are the different things we have to follow. Whenever I say 1:1, exact dimension I'm drawing. Whenever the denominator is more, I'm reducing this size. Whenever the numerator is more, I'm enlarging the size. And there are few types of scales. In your syllabus, there are total 3 types of scales. One is plane scale, a diagonal scale, and vernier scale. Plane scale use the plane symbol. Plane scale, they directly take the plane normal scale they take. Diagonal scale, they take the diagonally. They take the diagonal principle and they generate, because this is a rectangle. If you take, they use the diagonal principle. They use the diagonal principle for this rectangle and they will start. Okay. That's the reason it is diagonal scale. And next is a vernier scale. This vernier scale is generated by Paul Vernier, a mathematician. Generated this vernier scale. Based on this vernier scale, mm, vernier calipers has been generated. Okay, so it uses the vernier calipers principle in order to generate the vernier scale. And next are the few scales, comparative scales and scale of chords. It is out of syllabus, so we don't discuss these two scales. These two scales you can find it in your textbook, but in the only for mechanical and civil students they discuss this type of scales. For all the other branches they don't discuss 4 and 5 scales. Okay. Yeah, so I'm going to next slide. So there are few definitions you need to learn. First is the scale factor. First definition is the scale factor. First definition is the scale factor. I will take more 5 minutes so that we'll completing this one. First one is the scale factor. It is a ratio of length of the object represented on the drawing sheet by actual length of the object represented. So what happens is ratio of length of the object. So on the drawing sheet, I'm drawing 1 centimeter. On the drawing sheet, I'm drawing 1 centimeter, but actually it is 10 centimeter. Example. But actual size is 10 centimeters. But on the drawing sheet, I'm writing as I'm converting 10 centimeter to 1 centimeter. So what happens? 1 by 10. 1 by 10 centimeter. So this is my scale factor. We call it as SF. Okay. So similarly, for the length, drawing length by actual length, we take L and L. Next, if the problem they asked in terms of area, drawing area by actual area, L square by L square. Next, if it is in terms of volume, drawing volume by actual volume, L cube, because it is a square, we are representing in terms of length. So if already it is L square, L square, I want to make it as length. Then what I have to do is I have to square root of L square. If I make this square root of L square, then I'll get the L value. Similarly, for the volume, I have L cube. So I have to take it as cube root in order to find the value of L. Whatever may be the area or volume, I have to convert in terms of L. I have to convert in terms of L. So here I'll take cube root of L. It will become as L. Okay. So this is a scale factor RF. Without this RF, you can't solve the problem. Okay. Actual length. What is the drawing length you are making on drawing sheet by actual length? Suppose the building length is suppose 10 meters. 10 meters. And here we are assuming that this 10 meters I'm writing in terms of 5 mm. 5 mm. So in this problem, this 5 mm is a, if I draw a 5 mm line, it will become 10 meters of the dimension. Actual size is 10 meters of a building. On in the numerator, I'm writing the what is the actual dimension I'm taking here. Yeah, 43 roll number. I'll be sending the sheet 4 notes in our WhatsApp group or in the Google Classroom. I'll share these notes so that you can take. And while calculating RF, numerator and denominator should have same unit. Suppose the numerator is in mm, the denominator should also be in mm because it is a ratio. In the ratio, numerator denominator value should be cancelled. Okay. Suppose the numerator is in centimeters, denominator should also be in centimeters. Suppose the numerator is in terms of inches. Numerator is in terms of inches, denominator should also be in terms of inches. Okay. You have to use the same units, centimeter, centimeter, same thing. That is the main thing you have to calculate. Suppose the numerator you are taking centimeters and denominator you are taking it is the wrong value. Compulsory you have to take the same value. Okay. Next you have to find out LOS. LOS is nothing but length of scale. So length of scale is nothing but, suppose I want to represent 10 meters. This 10 meters, how much I am drawing here, they have to calculate the length of scale. This length of scale you can calculate only by RF value. Only by RF value you have to calculate. Length of scale equal to RF. RF is nothing but the representative factor or scale factor multiplied by the distance to be represented. Suppose I have to represent the distance as 100. 100 is the distance I have to take. Then RF comes as suppose 1 by 10. So this 1 by 10 into 100, I have to make, it will become as 10. So it will become as 10 centimeters. Okay. Suppose this value is 100 centimeters. Maximum distance is 100 centimeters. So I want to, I'm taking my representative factor is 1 by 10. So 10 cancel, it will become 10 centimeter. Okay, then I have to draw the 10 centimeter line. This 10 centimeter line will represent 100 centimeters based on the RF value that you have to solve here. Okay, so before solving the problem, you have to know this: what is the RF value, what is the length of scale, you have to calculate. And note, LOS is usually calculated in terms of centimeters or millimeters. So don't take other values, only take centimeters or millimeters, preferable centimeter. In this scales problem, you will be taking LOS value in terms of centimeters. And in some cases, they don't represent maximum distance. In some problems, they don't give the maximum distance. Then assume the round off value. You can round off to higher value, higher whole number you can make by using this one. Okay, and generally LOS will be in between 10 centimeter to 25 centimeters. If any LOS is crossing more than 25 centimeters, it means that you have done somewhere mistake. If it is below 10, is also you have done somewhere mistake. Generally the LOS will be between 10 to 25 centimeters, because your sheet has certain limitations. So that's the reason LOS will not cross greater than 25 centimeters. Okay,